Hello class, welcome to lesson 3.1, which is all about graphing linear equations. By the end of this lesson, you should be able to identify linear equations, intercepts, and zeros. You should also be able to graph linear equations. So let's start out with some vocabulary. A linear equation is an equation that forms a line when it is graphed. Standard form is when you have a number times x plus a number times y, and that equals a number, okay? So in order to be in standard form, you need your x and your y on the same side of the equal sign and set it equal to a number. A constant in the standard form equation is represented by c, and c just represents another number. Constant is a number. The x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. So that's all we have for vocab. A very important one is standard form. As we take tests and quizzes in this chapter, there are going to be multiple forms of writing equations. Make sure you keep them straight. The first one we're going to learn in this chapter is standard form. Let's look at our first equation. Determine whether each equation is a linear equation, and then write the equation in standard form. So remember, standard form, ax plus by equals c. Now, in order for an equation to be a linear equation, it needs to form a straight line, okay? That means that you have an x and a y, and that the powers are not greater than 1. So here we have 1/3 y equals a -1. So I see that I don't have an x, but I can rewrite this. It'd be 0x plus 1/3 y equals -1. If I were to graph this, I would end up with a straight line because my powers are 1. X to the first and y to the first, okay? So this is a linear equation. And in order for it to be in standard form, another thing, we don't like fractions for standard form. So instead of writing it 1/3 y equals -1, we want to get rid of that 1/3. And in order to get rid of that 1/3, we can multiply everything by a 3, because right now we are dividing by 3, and if we do that, we end up with y equals, because 3 times 1/3 is just 1, and then 3 times a -1 is -3. So that is our standard form for part A. Now let's look at part B. We have y equals x squared minus 4. And if we look at it, we have y to the first power, we have x to the second power. Since that's a number to, or a variable to a second power, that means we would end up with a shape like this somewhere on the graph. And that is not a linear function. So we would say not a linear equation. Okay, so go ahead and take a look at this first problem on your own, see if you can figure it out. Hopefully you ended up saying that it was a linear equation and that 4x minus y equals 5. Try one more on your own and see how you do. Hopefully for this one you said that this is not a linear equation. All right, so if you have questions about that, be sure to ask. Let's look at example 2. We want to find the x and the y intercepts of the graph. So if we look, we have a graph about gym memberships, and then the total cost is on our y-axis, the vertical line, and the number of months of gym memberships is the x-axis. Now, we want to determine our x-intercept and our y-intercept. Okay, so where does it cross the x-axis? Where does that red line cross the x-axis. Does it cross the x-axis? No. So that means there is no x-intercept. And if we look at y, the y-intercept, it crosses at 150 there. So our y-intercept would be 150. One thing to be careful of, going back to this x-intercept, it says no x-intercept. That is not the same as saying the x-intercept is 0. Be careful. No x-intercept means it never touches. If we were to say the x-intercept was 0, that means that this red line would be crossing x right there at the blue dot. So be careful about that, okay? Go ahead and try this one on your own, see how you do. Hopefully you determined that the x-intercept is 10 and the y-intercept is 250. If not, be sure to ask a friend for some help. And let's continue on. I'm not sure why my smartboard is being so glitchy. So sorry about the delays and from what I say and what appears on the board. But let's jump into example 3. The table shows the function relating the distance to an amusement park in miles and the time in hours the Laurent family has driven. Find the x and y intercepts. Describe what the intercepts mean in the situation. So, if we look at this, we have time and hours. Remember, time is always our independent variable. So that goes where we have our x-intercept, or our x-axis, and then the distance is dependent on the time, so that's our y. So we have distance in miles, and I guess time is in hours. So if we look, we have 0, 1, 2, 3, 4, 4. And then for our distance, we do 50. We go up by 50s, we have 50, 100, 150, 200, 250, 300. Okay. So if I quickly plot this, 0 hours, we still have almost 250 miles to go. After 1 hour, we still have about 180 miles to go. After 2 hours, we still have about 120. After 3 hours, we have about 62. After 4 hours, we have arrived. Okay? So, we just kind of sketched a rough graph to determine where our intercepts are. So we have a y-intercept of 248, an x-intercept of 4. Do you have to graph it when you see a table like this and it doesn't say you have to graph it? No. You can look. You can see this is we determined this was my x, this was my y. So here, remember x-intercepts, the x has a number but the y would be 0. And for a y-intercept, your x equals 0 and your y has a value. So it's totally acceptable to just look at a table and figure out what your x and y intercepts would be, but make sure you don't confuse them. It's really easy to see, oh, times 0, that must be where it crosses the x-axis. No, that is not where it crosses the x-axis, so just be careful about that. Go ahead and try this one on your own, see how you do. Hopefully you determined that the x-intercept is 5 and the y-intercept is 125, but just in case that's not what you got, feel free to try one more. Okay, and then hopefully you ended up with at time 0 or before any food stops, there was $125 on the card. Let's jump into our next example, example 4. All right, we want to graph each equation by using x and y intercepts. So the way that we are going to do that, there's a trick. When it's in standard form, what you can do is plug 0 in. So for our x-intercept, we need y to be 0, right? We need the y value to be 0 in order to be on that line. So what we can do, if we plug 0 in, that means that goes away because 2 times 0 for y is 0. So I have a negative x equals 3. So negative x equals 3. And I don't like having negative variables. So what I can do, right now, this is like a negative 1 times x. I can divide by negative 1. And I'm left with x equals negative 3. So when y equals 0, x equals negative 3. So my x-intercept is at negative 3, so that means I'm going to go on the x-axis left 3. And then in order to figure out my y-intercept, I'm going to do roughly the same thing. I'm going to plug 0 in for x so I can just cover that up. And I'm left with 2y equals 3. And if I solve for y, I'm going to divide both sides by 2. And I'm left with y equals 3 halves. So when x is 0, y equals 3 halves. So that means 3 halves is 1.5. So I'm going to go up to 1.5. So my y-intercept is 3 halves. And then to finish graphing, I just have to connect my dots. I'm going to request that you guys use a straight edge as you do this in order to get some nice looking graphs. Feel free to use the graph paper that you find over by the window. And let's try one more example. So we have letter B, we have y equals negative x minus 5. The first thing I want you to do, rewrite this in standard form. Remember, standard form has the x and y on the same side of the equal sign. So that means I'm going to add x to both sides. So that way both my variables are positive. And I now have x plus y equals negative 5. So then if I want to find my x-intercept, or where when y is 0, I'm going to cover up my y, even though it looks like it is still showing. So let's quickly do that. Okay, so now we've covered up our y. Our y equals 0. That means our x equals negative 5. So my x-intercept is negative 5. So I'm going to go to the left 5. And then let's quickly do our y-intercept. If we cover up our x, we also have y-intercept is negative 5. So I'm going to go down 5 on the y-axis. And then to finish it, I just connect them. And again, I want you guys to use a straight edge. You can also find the straight edges over by the window with the graph paper. And hopefully graphing won't be so bad. But just remember, in order to find your x-intercept, you have to plug 0 in for y. And in order to find your y-intercept, you need to plug 0 in for x. Go ahead and see if this is the correct graph for 2x plus 5y equals 10. Hopefully you determined it was, but if not, be sure to ask some questions or rewatch the last example. Okay, let's look at example 5. This is our last example for this video. So we want to graph each equation by making a table. We've made a lot of tables before in this class and previous classes, so I went ahead and I started the table already to save some time. The points I want you to test when you have equations that look like this, I want you to test negative 2, negative 1, 0, 1, and 2. Okay? So if we plug a negative 2 into that equation, we have 2 times negative 2. So we plug a negative 2 in for x. So that gives us a negative 4 minus y equals 2. So if I solve, I add 4, I add 4, I have negative y equals 6. In order to get that negative away from the y, I'm going to divide by negative 1. Divide by negative 1. I have y equals negative 6. That means my xy, in order to graph the ordered pair, is negative 2, negative 6. So I can go left 2 and down 6. There's my first point. Now I plug in a negative 1. If I do that, I have 2 times the negative 1, so I have a negative 2 minus y equals 2. So again, if I add 2, I have negative y equals 4. Divide by negative 1. I have y equals negative 4. So I have negative 1, negative 4. I quickly plot that. I go left 1, down 4. If I plug 0 in, I have 2 times 0, that's 0. And then I have negative y equals 2. I hope you see this little trick. I've been dividing by a negative 1. If you have a negative variable, all you have to do is change the signs. So if I change the y to positive, everything else I changed to I flipped to the opposite sign. So I had a positive 2, so that becomes negative 2. So negative 2, I have 0, negative 2, 0, negative 2. Alright, and then if I plug 1 in, I ultimately end up with 0. So I have 1, 0. And if I plug 2 in, I get 2. I get 2, 2. Just going to do that to save some time. And then I would connect these dots using a straight edge on my graph paper. And that would be the graph for this letter A. Now, let's quickly do letter B. We have x equals 3. Okay, so we are already told what x equals here. So 3, 3, 3, 3. I can plug 3's in for the entire x column. And then there's really no y in this example, is there? So if I plug those same points in, my negative 2, negative 1, 0, 1, 2, there's nowhere to plug this number into this equation. So when y is a negative 2, x is a 3. When y is negative 1, x is 3. When y is 0, x is 3. Same with 1 and 2. So that means when you have an x equals a number, you're going to have a vertical line that looks like that. Okay, and your points would always be 3, negative 2, 3. All of your points would look like that because we already said x is always 3. Okay? So, when you have an x equals a number, you get a vertical line. When you have an x and a y, you get a diagonal line or slanted line. Now, let's see what happens when y always equals negative 2. So when x equals negative 2, negative 1, 0, 1, and 2, because those are my points, I have nowhere to plug in an x. So that means these become my points. I have a negative 2, negative 2, negative 1, negative 2, and so on. Okay? So I go left 2, down 2. I go left 1, down 2, straight down 2, over to the right 1, down 2, over to the right 2, down 2. So my y equals negative 2 means that I get a horizontal line. So when you have a y equals, that's horizontal. X equals is vertical. And when you have x and y, it is slanted. Oops. Slanted. Oh, this is super glitchy. I'm sorry, guys. Okay, so slanted. All right. So maybe make a note of that in your notes so that way you remember. And go ahead and try your last problem for the day. Hopefully you decided, no, this is not the correct graph for y equals 3x minus 4. If it was 3x minus 4, you would have had a line that would have looked something like this. So going the other way. Okay? All right, and that's all I have for this lesson. So if you have any questions, be sure to ask myself or a friend. Have a fantastic day.